Hello, chemistry students. We're going to continue talking about compound stoichiometry and more specifically empirical formulas. There are a few terms that you need to know about first. What is a molecular formula? The molecular formula is the true formula of a molecule. An empirical formula, it's the lowest whole number ratio of atoms, and that can represent several different atoms. Ionic compounds will only have an empirical formula. So an example of this would be CH2O. This has a subscript of 1, a subscript of 2, and a subscript of 1. That is the lowest whole number ratio. So this would be an empirical formula. In C2H4O2, each of these subscripts can be divisible by 2, so it is not at its lowest whole number ratio. So this would be a molecular formula. Okay, so what do the subscripts represent in the molecular formula? They represent the actual number of atoms in the molecule. So back again, CH2O, these subscripts mean that there is 1 carbon, 2 hydrogens, and 1 oxygen. And this one, C2H4O2, this 2 means that there are 2 carbons, this 4 means there are 4 hydrogens, and this 2 means there's 2 oxygens, so the actual number of atoms. So how do the subscripts differ for the empirical formula? Well, the empirical formula right here has the smallest whole number ratio. It can't be, these subscripts cannot be divisible anymore. Let's do an example. So the molecular formula is C6H12O6 and the empirical formula is CH2O. How many empirical formulas or empirical formula units, EFUs, are needed to make the molecular formula? So we know the empirical formula, this is the smallest whole number ratio, and this is the actual molecular formula. There are 6 carbons, 12 hydrogens, and 6 oxygens. So how many of these will make up this? Well, we notice there are 6 carbons, so we need 6 carbons in our molecular formula. In order to do that, we would need 6 CH2Os. We've got 1, 2, 3, 4, 5, and 6. And if we combined all of those together, we would have 6 carbons. We would have 12 oxygens, 2, 4, 6, 8, 10, 12. And we would have 1, 2, 3, 4, 5, 6 oxygens. So there are 6 CH2Os in C6H12O6. All right, next example. What is the molar mass for the empirical formula CH2O? Okay, in order to do this, we need to add all the atomic masses together. We have 1 carbon, so we're going to do, carbon is 12.01 times 1. And hydrogen is 1.01 times 2 because there are 2 hydrogens. And oxygen is 16.0 times 1. We add all those together. And the molar mass for our empirical formula is 30.02 grams per mole. So how does it relate mathematically to the molar mass of C6H12O6? Well, this is 6 times 12.01, and hydrogen is 12 times 1.01, and oxygen would be 6 times 16.00. And that is 180.18 grams per mole. And this is equal to the molar mass of molecular formula, MLCl. Okay, and we know that the molar mass of our empirical formula is 30.02. Now we know that there are 6 empirical formula units of CHO in C6H12O6. So if we take our molecular mass of our empirical formula, which is 30.02, and multiply it by 6, we'll get 180.12. And that's awfully close to 180.18. The molar mass of our empirical formula is 1/6 of the molar mass of our molecular formula. Now we need to find out how to calculate an empirical formula. The first step, you need to write these down, is you convert from percent to mass. And you always assume that there are 100 grams. You drop the percent label and add the grams label. So if we say that there's 42% oxygen, we are going to change that percent to grams, and we're going to say that it's 42 grams of oxygen. Step 2. You convert your mass to moles. So you convert the masses found in the first step to moles of each element. And you always leave at least 4 significant digits. Third step is you divide by the smallest moles. You find the element that has the smallest amount of moles, found in step 2. You divide all the moles by this amount. Fourth step, you multiply till whole. You must end in a whole number. This will make more sense in a few minutes. We'll go through an example. Okay, in order to multiply till whole, like for instance, if your number ends with a 0.2 or a 0.8, you're going to multiply by 5. If it ends in 0.25 or 0.75, you're going to multiply by 4, 0.33 or 0.67 by 3, and 0.5 by 2. You'll want to memorize this saying, so write it down. Percent to mass, mass to mole, divide by smallest, multiply till whole. That'll help you to remember the steps that you need to go through to find the empirical formula. First example, our first step is to convert from percent to mass. It says a compound is found to contain 34.39% zinc, 14.82% nitrogen, and 50.79% oxygen. What is the empirical formula of the compound? So zinc, we're going to convert our percent to mass, so it's just 34.39 grams. And then we have nitrogen, 14.82, we're converting our percent to mass. And then oxygen is 50.79 grams. Step 1's done. That was easy. Step 2, mass to moles. Okay, so we have our masses. In order to convert this to moles, we have to use molar mass. We divide by molar mass. We need to find the molar mass of zinc. Zinc is 65.38 grams in 1 mole. So I'm going to take this and I'm going to divide it by 65.38 grams in 1 mole. Okay, if you notice here, this is grams per mole. And our grams cancel out and we're left with moles, which is what we want. And that is equal to 0.5260 moles of zinc. Okay, we need to leave 4 significant digits. All right, for nitrogen. Nitrogen is 14.01, so I'm going to divide this by 14.01 grams per mole. And that equals 1.0578 moles of nitrogen. Next, we need to find out our moles of oxygen. So we need to find out our molar mass is 16 grams per mole. So it's going to be 50 divided by 16 grams per mole. Our grams go away and we're left with moles. And that equals 3.1744 moles of oxygen. Okay, our next step is divide by smallest. Now I'm going to look at, these are all of our moles of each of our elements. The smallest one is zinc, 0.52600. That has 5 significant digits, I apologize. So 0.5260, I'm going to divide everything by 0.5260. This is equal to 1. 1.0578 divided by 0.5260. is equal to 2.011. So let's say if it was equal to 2.211, we would round it to 2.2. 3.1744 divided by 0.5260 is 6.03. So I'm going to round that to 6. Next step is multiply till whole. Well, we have our numbers and they're already whole numbers. It's a 1, a 2, and a 6. They are already a whole number. So we are at our last step. So that means that there is 1 zinc, and we never put ones. There are 2 nitrogens, and there are 6 oxygens. So our empirical formula is ZnN2O6. Now I would like for you to practice this example. Come back and check your answer.